Deployment of dependencies seems to be a common problem in Kubernetes. People tend to search for ways to define that A depends on B and that B depends on C and D and so on and so forth. For example, engineers might wonder how to deploy a database before a schema which should be applied before the application, which should have a namespace created in advance. Search for answers for such questions often result in frustration because there is no good solution, or because those we find result in adoption of bad practices, horrible practices, or not so good practices. You see, the search for ways to manage dependencies, at least when Kubernetes is concerned, is a search for a solution to a problem that does not exist. It's an attempt to solve an issue we had in the past when we, humans, were making decisions what should be deployed first, what goes second, and what goes last. We're trying to apply the logic we used in the past when we were deploying applications by SSHing into servers, or when we were orchestrating deployments through pipelines or scripts. The world has changed, especially since the emergence of orchestrators like Kubernetes. So let's talk how to manage dependencies in Kubernetes. Imagine the following scenario. We have application A that needs to talk to the application B. That same application has a database where it keeps its data, so it needs to talk to it as well. For that to work, the database needs to have a user and a schema. Moreover, if that application is running in Kubernetes, it would need to have a namespace as well. Otherwise, there would need to be a server or something else where that application would run. There are quite a few dependencies, even for such a simple scenario. The application A depends on the application B, the database, the DB user, the DB schema, and the namespace. Further on, the DB user depends on the database itself, and the schema depends on both the database and the user. If those dependencies are not satisfied, the application A would not work. It could not talk to the application B, it could not store and retrieve data from the database, and it could not even run in Kubernetes without the namespace. So, some things depend on others, and that means that we need to ensure that things are created in certain order. We need to ensure that the application B is created before the application A. Next, we might choose to run the database, then to create the user, followed by the schema, and finally the namespace. So, the order through which we would create stuff could be up A, then the DB, then the DB user, then the DB schema, then the namespace, and finally the application A. The specific order is not always important. We could have started with the namespace instead of creating it near the end. What we cannot do is create the application A before, for example, the namespace itself was created. That would fail miserably, right? Well, let's see what would happen if we did not care about the order and stuff was created randomly. To make things more interesting, let's assume that the application A was created first, before anything else. What would happen in that case? Well, it would try to talk to the application B, which does not yet exist. Now, that might or might not be a problem. If we design our applications in a way that they fail miserably when any of their dependencies are not available, we can say goodbye to any kind of resiliency and high availability. You see, even if the application B was created before the application A, it could fail at any moment. So we would need to design the application A to continue being operational even if the application B is not. That has nothing to do with the order in which the stuff is deployed, but rather resiliency and the acknowledgement that parts of the system can fail at any moment. If we do make our applications resilient, it should not matter whether the application A was deployed before or after application B, since the app A should work somehow without it, maybe by creating queues or something similar. And once the application B becomes available, it should start working with that dependency. Again, all that has nothing to do with the order, but with the resilience, with the side effect that the order of deployment does not matter. Now, I know that's not how everyone designs their applications. I know that some applications were designed to work only when all the dependencies are running or not work at all. So I will assume that application A was designed in that way. So let's make a different assumption. Let's assume that the application A has a health check that fails, among other ways, when the application B is not available. Let's say that the application A cannot even start without the application B. That would be good news, since that would mean that Kubernetes would restart the pod of the application A because it is failing the health check. Kubernetes would keep restarting the app A or application A until at some moment the application B becomes available. We'll get back to that dependency a bit later. For now, let's switch our attention to the namespace. The application A should run in a specific namespace. What happens if the namespace does not exist? Well, that depends on how we're deploying applications. We could be deploying them by executing commands like kubectl apply and helm install or something else. But that would be silly. We don't do that anymore. That's how we did things in the past. Today, we tend to use GitOps tools like Argo CD and Flux. Those tools are watching Git repositories, and when they see changes, they deploy the changes to Kubernetes. So from now on, I will assume that all those resources we are discussing right now are in a Git repo, and that Argo CD or Flux is watching that repo and deploying the changes to Kubernetes. That, however, still does not mean that we control the order in which the resources are deployed. So the story is the same, except that a failure to create something will result in a loop of attempts to create that something. So a GitOps tool tries to create the app A and it fails because there is no namespace. What does it do? It tries again and again and again until at some moment the namespace is created and the app A, application A, is deployed. However, the fact that the application can now run in the specific namespace does not mean that it can talk to the database. The database does not exist yet, so the application A cannot talk to it. Actually, the application cannot talk to the database not because the database does not exist, and this is important, but because it does not have the IP and the user and the password to access that database. It does not have that data because it tried to mount a secret that does not exist. The secret with authentication does not exist because the database does not exist. However, once the database is created, it will create the secret and the application A will be able to mount it. Until that moment, Kubernetes could not create the pods of the application since it could not find the secret to mount into those. Even when the database is created and it creates a secret with the IP and the master credentials, the application A still cannot mount the secret because the user it needs to use does not exist, neither in the database nor in the secret. Just as pods of the application could not be created, the user could not be created without the master credentials to the database. So that process was failing, but when something is failing in Kubernetes, Kubernetes tries again and again and again until at some moment the database is created and the user is created and the secret with all the information is created. From that perspective, the application does not depend on a resource like a database, but on data, which in this case is the information how to access the database. Now, finally, the pods of the application A, those same ones that could not be created before, can be created now. So the application A can start and it can talk to the database, but there is no schema in the database. Schema was not created for the same reason why the application could not run until recently. It needs a secret with the credentials to connect to the database and create the schema. That process was also failing and being restarted until at some moment the secret was created so the process that manages the schema could create the schema. Now, during that time, the application was trying to talk to the database and it was failing. Unlike other health checks, it could be complicated to create one that verifies that the correct schema exists in the database. So this is the first time we're faced with a real dependency. You see, even if we could validate that the schema is applied, it would be complicated to validate whether the correct schema is applied. Schemas can change from one release to another, and while there are ways to check which version of the schema we're running, I will assume that we did not do that because we are lazy, right? So for lazy people, and I repeat, it can be done. It's not a big thing, but For lazy people, the schema is the first real dependency that has to be applied in a specific order. We'll talk about that in more depth later. For now, what matters is that the code of that application was throwing errors because it could not insert data to a table that did not exist. But now that the schema was applied, that problem is gone and everything works as expected, except for the communication with the application B, the other one. Actually, that was not the problem, since we already established that it would be silly to design the application A in a way that it cannot work without the application B. Eventually, the application B started working and the application A started talking to it. So everything is working now without us thinking about the order in which the resources were created. There was no need for us to say, do this, then do that, except maybe, just maybe, for the schema, which we'll explore in more detail in a few moments, I promise. The lesson learned is that we do not need to define explicit dependencies nor the order in which the resources are created. Resources depend on information, and I repeat, not resources, information from other resources. For example, the application A tried to mount a secret with the credentials to the database. The secret was created by the process that created the database. The pods of the app were failing until the secret was created. Everything ended up being eventually consistent, and the end result is the same as if we explicitly defined the dependencies and the order in which the resources are created. Now you might say that it's easy to rely on machine orchestration the first time we run stuff, since we do not yet have users. Without the users, it does not matter whether the app is operational right away or not. What matters is that the first release is eventually fully operational. So it's okay for the first release to be eventually operational, but what about the second and the third and the fourth? Once the app is working and it has real users, we cannot afford downtime. So that's when we do need to think about the exact order in which we do things, right? So we have version 1 of both applications. Actually, the application B can be any version, since we typically do not release all apps at the same time, right? If that's what you're doing, I honestly don't understand why you have separate applications and do not go with a massive monolith. Anyways, both applications are running and now we want to release a new version. There are a couple of different scenarios here. One option is to have the architecture of the applications in a way that everything always needs to be released at the same time. That's impossible. Impossible unless you literally create whole application in parallel and then, the whole production, the whole system in parallel, and then you switch to it, right? Even in that case, there will always be requests that are being processed in the old and requests that are coming to the new version. Then there is the issue with data and database schemas and plenty of others anyways. I will just go ahead and say that releasing everything at the same time is impossible. If by the same time we mean literally the same time, like millisecond precision, right? Something will always come up sooner or later. Some requests will be in progress while the new ones are coming. So releasing stuff at the same time is not possible. And if that's what your expectations are, the best you can do is seriously regret the decision to split applications and just go back to one massive monolith. What will happen is that you will, let's say, release version 2 of the application B first. And that means that applications API will be, and I repeat, will be backwards compatible, and the application A will continue using version 1 of the application B's API. Then you will release version 2 of the application A, which will start using version 2 of the application B's API. Version 2 of the application A might be released a second, a day, or a week later. It might never be released. It does not matter. What matters is that we write code that uses APIs of the dependencies that are in production. And when we do that, the order does not matter. What matters is that the application B has a separate life from the application A. It keeps getting new releases, and the owner of application A, can decide which of those production releases to speak to. APIs are always versioned, and are available until we decide to deprecate them with a sufficient advance notice, right? We need to tell people in advance that we are going to deprecate an API, not just remove it from one version to another, from one release to another. So applications, not to call them microservices, have separate lives and have APIs that are versioned and are backwards compatible. As such, it does not matter which one was released first and which one comes second. Some applications depend on the others, but not from the orchestration perspective. And that leaves us with other dependencies like databases. For the moment, I will assume that each application has its own database or does not have a database at all. Long gone are the days, it's been a while since it was normal that we have a single database for all applications. A single database server? Maybe. A single database? Absolutely not. So each application has its own database and each database has its own schema. That means that an application is not a single binary or a single container image anymore. An application is a collection of all the resources that belong to it. And that, in our simplified scenario, means that an application is the app itself, probably a container image, the database schema, and everything else that directly depends on it. That means that the rules of versioned APIs and external dependencies that are always what is in production and not what someone is cooking do not apply anymore. That means that in some cases we might need to define the order in which the resources are created. That is the case of database schemas. A new release of an application might require changes to the schema, and that schema might need to be applied before we start rolling out the new version of the app binary. Now, to be clear, that database schema change still needs to be backwards compatible. There is no way around it if we want to avoid downtime. The new schema will be applied before the new version binary is rolled out, meaning that the old application binary will be using the new database schema. What matters though is that we finally got to the point where eventual consistency is not always an option. Schema might need to be applied before the application binary is running. One is an implicit dependency of the other. Ordering finally matters. However, ordering is also easy. It is complicated to orchestrate the order in which individual components of different applications are deployed, but not components of the same application. If, for example, we are using Argo CD, we have sync waves to define the order. Sync waves do not work between different applications, but do work like a charm between different components of the same application. Flux depends on field in the manifest. Helm has hooks, and so on and so forth. Now, sometimes applications are not divided well. Sometimes there are components that are shared. For example, you might have a single database server serving multiple applications. Database server is, in those cases, a shared component. However, that does not mean that each application cannot have a separate database in that server and each of those databases can have a separate schema. In those cases, the logic is still the same. There is a clear separation between the applications, and when necessary, we can orchestrate the order of deployment of internal components of that same application while letting the system orchestrate everything else. Or you might have a database, not only the server, shared between different applications, the same server, the same database, and the same schema used by multiple applications. Now, this is very important. If that's your situation, you should know this. That's silly. Don't do that, ever. Don't do that. And if you do, don't complain about the complexity of managing dependencies. All in all, the next time you start looking for a solution to manage dependencies and to decide the order in which things are deployed, stop. Don't do that. Let the system be eventually consistent. If that fails, you're likely doing something wrong. And that something has nothing to do with the order in which the resources are created. The exception might be, when there is no other way, the order in which the resources of the same application are applied. And here comes the important part of the story. Instead of thinking about dependencies in terms of resources, we should think about dependencies in terms of data. Instead of saying, this application depends on a database, we should say, this application depends on authentication data for the database. This application can connect to the database when it has the information about the database. The data. Instead of saying that the schema should be applied before the new release of the application binary is rolled out, we should say that the new release of the application binary should be rolled out only when the specific version of the schema is available. Data a specific resource needs is either available or it isn't. And when it isn't, the resource cannot be created. That's how Kubernetes patching works. A resource can be applied only after all the patching is done. And if patches are data from other resources, those other resources need to be created first. Now, here's something that will probably make you think that I went crazy, that I'm insane. Explicit dependencies and the order they are created does not matter most of the time. But here's the important part. The dependencies and the order they are deleted does matter. However, the deletion order is a subject by itself, which, if you're interested, I can explore in a separate video. Thank you for watching. See you in the next one. Cheers.